Hello, welcome to another video. In this video, we are going to visualize the cluster workload of Kubernetes cluster with a tool called Octant. So let's see what we are going to do as part of this video. First, we will visualize the Kubernetes cluster using the default UI provided by Kubernetes. Then we will visualize the same Kubernetes cluster using a tool called Octant. So for the demo, I will use the setup which I used previously for my Kubernetes-based event-driven auto-scaling series, the KEDA. So this demo deploys onto a Kubernetes cluster a producer, a .NET exe, which produces a configured number of messages onto a RabbitMQ, and there is a consumer which consumes these messages in a batch of 50, which is again configurable, and then it scales the consumers based on the number of messages in the RabbitMQ. So let's look at what is Octant. Octant is an open source developer-centric web interface for Kubernetes that allows us to inspect the Kubernetes cluster and its application. It provides visualization to manage the Kubernetes objects, and it complements the existing tools like kubectl or kubectl and customize. It also allows us to extend through the cluster views by a plugin system, and it's quite versatile in terms of the features that it has. So let's see, what do we need to get started with Octant. In order to install Octant, we could use a package for the Linux distribution, or if we are on Windows or Mac OS, we can use Chocolatey or Scoop to install, and on Mac we could use Homebrew to install the Octant package. If we are not fan of the package manager, then we could also install Octant using a pre-built binary for the specific OS by visiting the release page of Octant project, downloading the zip file or tar, extracting it, and then running the Octant binary. So instead of wasting time on looking at the slides, let's get started with the actual demo of this particular tool. I have the Kubernetes cluster, and if we are familiar with the kubectl, people often use kubectl, the command line tools, to understand the cluster state. So here I have a 2-node cluster, and if I want to understand the node state, I can use a command like kubectl describe, and this will give me details about the particular node. So I will get to know the name, the roles, the labels for that particular node, the annotations, the different scheduling options, the conditions through which the cluster node went through, and the capacity allocations, and all these details which are related to the particular node of the cluster. The other option we have is to use the proxy from our local laptop or local machine and connect to the Kubernetes control plane or the dashboard. So in my case, I have a script which connects to the Kubernetes cluster. So since I'm using Azure Kubernetes Service AKS, I have a script which runs the AZ-AKS browse command with the resource group name and cluster name. And this creates a tunnel, a proxy, and it runs on the localhost 8001 port. So when I run this browse script, it brings us to the default UI of Kubernetes, which gives us the overview of the cluster. We can see here the workload status in terms of deployments, the pods, replica sets, stateful sets. Then in terms of the details of each of this, we can see the lists here. We can also navigate to the specific type of objects like pods or jobs. Let's look at the pods, for example. So we can see here that there is a RabbitMQ producer deployment pod running. There is 2 instances of this, and there is 1 instance of the RabbitMQ pod running. So the same information I can see on the command line as well. If I go back to the kubectl, I can run a command saying get pods, and I will get the same output what I see on the UI. But on the UI we find much more details. So if we go into the pods specific pod, we will find additional details related to that particular pod, like what is the running status, what's the class of service, which is the node where it's running, what's the IP, the container details for a particular pod, and the events using which this pod was created. So this information is coming from the default view of the Kubernetes dashboard. Now let's see how we can get the same view or similar view using Octant. So to use Octant, we can just invoke the Octant binary, and this will open the Octant UI for us. The first thing that we see is a difference in the UI, which is the context. So the default Kubernetes cluster, it doesn't have the context switching option. You can only connect to one particular cluster at a time, whereas using Octant, we could switch the context. And this looks at the kubeconfig file, and whatever context are specified in the kubeconfig, we can switch to any of one of those particular contexts. So this we can verify by running the command here on the command line kubectl config and get context. So all the contexts that are configured on my kubeconfig file, I'll be able to see that in the Octant UI. So I find this as one of the useful feature. So instead of switching the context every time, I could use the UI of the Octant to switch the context for a particular Kubernetes cluster. The other option we see here is the way the UI is organized. So it is similar to what we see on the default UI. Like it has on the left hand side all the different kind of options, all the different objects, different types of objects which Kubernetes supports. So we see the similar thing here, but it's nicely organized in terms of the workloads, the discovery and load balancing configuration. The focus here is more on the cluster workload, and then the cluster overview comes at the bottom. Whereas on the default Kubernetes dashboard, we see the cluster overview coming first. Now let's look at the pods, for example, similar to what we saw on the default cluster. So the first screen is somewhat similar in terms of the listing, but the thing which is slightly different is the number of restarts, the phase. This is depicted here. Now let's go into one of the running pod, and we see the summary, the configuration of that particular pod, and the status. So the information which Octant shows, I personally feel that it is much more organized in terms of different aspects of the pod, like metadata. It is clearly identifying the metadata here, whereas in the default one, let me choose the same pod. So I'm looking at a pod ending with G2 MCD. So in the default one, let's go in the same pod. So we find the same information on the default dashboard as well, but the way it's represented is, I feel, a bit messy compared to the very well organized way of the Octant here. So in terms of the pod conditions, we see the same status. Then the container status as well, which container is related to this particular pod. And this is an additional feature which I like. If we want to forward the port for this particular container, we can do it directly from the Octant UI, and it will expose a port on our local host. And once we are done, we can stop the port forwarding. So I don't find such a feature in the UI of the default Kubernetes dashboard. The other feature which is good is in terms of the resources. So it shows for the particular pod which we are looking at, what are the requests in terms of memory, CPU, and the limits. The volumes are depicted here. Affinity and anti-affinities are clearly depicted. Same with the taints and tolerations. So this is not available in the default UI. So that is definitely a addition, or good addition, I would say. Then the other part, which is my personal favorite, is the resource view or resource viewer. This gives us all the resources which are related to this particular pod. So if we look here, we can see that this pod is related to a replica set or created via a replica set, and that replica set is linked to which deployment, what is the account which is used for creating this particular pod, what is the service which is linked to this pod, and what is the secret which is linked to the pod. So this view is very handy in my opinion. So sometimes we create secrets, and since things like secrets and environment variables are key value pairs, we might miss something in terms of creating the key and value, and that might not link properly. This view will show us all those links, and we might be able to identify the problem easily via this visual representation of all the elements which are related to the pod. Other good feature is also this YAML view or YAML representation, and as we can see here, it's very nicely laid out in terms of the way YAML is structured, as well as the color coding. So we see that the values are color coded. So the environment variables and all the values, they have the numeric values are represented in a different color as compared to the textual representation of the values. We can also look at the logs, and this is showing the logs at the deployment level or related to this particular pod. If the deployment contains multiple pods or containers, we can also switch between the containers here. We do have the logs view on the default Kubernetes cluster as well. So I can go to the logs here, and this will actually open a new window to show the logs. So we can see the same logs but into a different window. So I find this again as a handy feature of Octant. So now let's look at replica sets, which is the other kind of object, and let's look at the replica sets on the default Kubernetes UI as well. So there are two replica sets on this particular cluster running. Let's look at the producer one. So the details are similar to the pod. We have the details at the deployment level or the replica set level, saying what is the image, what's the selector, creation time, annotations, the number of pods running, the two instances of the pods which are linked to this replica set, the service which is exposing those pods, the horizontal pod autoscalar, and any events. Now let's look at the Octant when it comes to the same replica set, and again we see a difference in the way it's organized. So we see the replica count, current and desired, clearly distinguishing what is the current state and what is the desired state, what are the number of replicas, then the annotations and the values. So again clearly distinguishing these annotations. This is another feature which I like in terms of status. So it shows like a grid saying how many waiting, how many failed, succeeded, and running, the two pods, the phases, and the pod template. And again, the way these are represented, I find it quite useful in terms of the way the metadata and the actual state of the replica set is represented here. We have the option of editing. So in terms of edit, I can only edit the name of the image here that is used for the producer. Whereas when it comes to the default Kubernetes dashboard, I can edit, and this gives me the complete YAML and I can edit almost any information here and I can update it. So in terms of edit, I would say the default Kubernetes dashboard is slightly better if you want to edit multiple properties and not just the name of the image. Then let's go and look at the deployments. So deployments, we have the producer deployment and 2 deployments running. If we go and click on one of the deployment or the deployment details, we again see a UI which is similar to replica set and pods, where the metadata is at the top, and then we have the details related to the new replica sets, old replica sets, horizontal pod autoscalars, and the events. Let's look at the same when it comes on the Octant. So deployments, we look at the same producer deployment here, and again we see the information is nicely laid out. So we have the option of editing the configuration, in this case updating the replicas, number of replicas from 2 to any other number that we want, and it shows the status again nicely separating in terms of how many are ready, how many total replicas are required, and how many are available or unavailable. The metadata is nicely organized. The pods are here, the conditions are also displayed here, and finally the pod template. So again, if we go to edit here, like the pod, we can only edit the name of the image here. And if we look at the default dashboard, we can again edit almost any information in the YAML. And in terms of scaling, we have the option of scaling, which is similar. So here we show the default dashboard shows what is the current status, what is the desired, and the actual number of deployments. We could scale it the same way like we do in Octant. So again, when it comes to the deployment, we have the resource viewer, and we can see how this deployment is related to the overall state of the cluster. And this is similar to what we saw in the replica set or pod view, resource view, and how each of these resources, they link to one another. Next, we can look at the horizontal pod autoscalar. So here again, we see that the options are similar to the other objects like the pod and the replica set, and the events here, we see them in the descending order. So the first event which occurred is at the right bottom, 59 minutes, and the last event which occurred is at the top, like 55 minutes here. Whereas in the default case, we see this in the reverse direction. So let's go to the same object here. We are on horizontal pod autoscalars. If we go to the horizontal pod autoscalar, in fact we can't find the horizontal pod autoscalar in this case. So let's go to the pods. We should have the same events running there. So let's look at the same G2 MCD pod. So I go on the Octant back pods, G2 MCD pod, and the event, or let's look at the deployment. No, I'm not finding the right information here. So again, pod. Let's look at the other pod running here. Pod condition initialized ready. This is okay. Let me do one thing. Let me trigger a workload which will actually create new pods, and we might be able to see it in better condition in the real time. So we have the message which is producing 2000 messages onto the RabbitMQ running successfully. So now when I come here, we see that the consumer pods are getting created. These are getting scaled. So if I go onto one of these consumer pods and we look at the status here, so we can see the pod conditions starting, pod scheduled, containers ready, and initialized. And at the bottom we can see the events. So in this case we can see that the first event which occurred is right at the bottom. So this is in the descending order. We are seeing the events listed, whereas if we go on the default Kubernetes UI, so let me take the same NZ-MSL pod on the default UI. NZ-MSL, I think it's on the next page. Here, NZ-MSL. And if we look at the events here, so it's showing the scheduler first and then the pulling image successful, created and started, whereas in the Octant this would be in the reverse direction. So created, started would be coming on top and the scheduled one will be at the bottom. So this can be helpful when we are investigating a problem or debugging a solution, and if the events are represented in the reverse chronological order, it could be easier, in my opinion, to find the solution or what is the root cause of the problem, as compared to if there are many events running here, we will have to go next to find out where is the last event, whereas in Octant the last event is coming right at the top. Next is the cluster overview. So in the cluster overview, we see the namespaces, cluster roles, and cluster role bindings. This is similar information which is available on the default cluster dashboard as well. We see the names, nodes, persistent volumes, roles, storage classes depicted here. In the Octant, again, the amount of information which we see is different, or the way it's represented. It shows the role kind and the role name associated with role bindings, whereas on the default dashboard this is represented slightly differently. So we need to go into the roles, or we need to go into the storage classes. So this information is like 2 levels down, whereas Octant has it summarized in one place. It also has all the port forwarding. If there was any port forwarded, we would see it here. In case of nodes, again, when we go into the node state, the information is similar to the objects that we saw with pods or replica sets. So very well organized in terms of the images that are deployed onto that particular node. Again, we can see the sizes of those images, the labels or the names associated with those images, and on the default ones, let's choose the same node. So I'm looking at 1633. So here I think the representation of allocated resources is slightly better in the default dashboard. We do see what are the pods deployed on this particular node, which is the similar information. So instead of pods, it's showing the names of the images. and the way the resources are represented is like a tabular view here, whereas the default cluster dashboard shows them in a graphical view. So I think this is better in the default view as compared to that of Octant. Octant also has this filter on the namespaces, so we can provide or we can filter based on the namespace name, and all the objects here on the left hand pane would get automatically adjusted based on this filter. Similar feature is available on the default pane as well, or default dashboard. So the next one is in terms of the configuration, persistent volumes, secrets, service accounts. These are again available in the default namespace as well, or default dashboard. So we have ingress and services listed under discovery and load balancing, and the config and the storage under the config section. So let's go back to the default namespace, and we see the number of pods getting updated here in real time. This the frequency is quite fast. It's almost near real time in Octant, whereas on the default one I think it takes a little bit of time, and I don't see the option of changing this frequency. We need to change the object to some other selection and then come back to see the changes. So this real-time view of Octant is again quite handy. So we can see that the number of pods they're getting reduced here, and almost instantaneously we can see the count decreasing. This doesn't happen so easily in the default dashboard. And the another useful feature of Octant is we can filter by labels. So if we have a label as such like app and RabbitMQ producer, for example, I can use that to filter. Let's run. I don't have the app, so let's filter based on run RabbitMQ. So you can see that this particular filter, the label, all the objects which match this label will be filtered here. We can also look at the custom resources which are deployed onto this particular cluster, and in the default one I didn't find the option to look for the custom resources. So that's another advantage of using Octant, to find the custom resources. And here we can find all the cluster level events. So with that we can go back to the presentation. So we looked at the default Kubernetes dashboard, which provides access to all the Kubernetes objects. We found that sometimes it's difficult to navigate, especially when it comes to looking at the logs, which opens a different window, and the default cluster dashboard also does not provide one single link between all the objects. Whereas when we look at the Octant, it does extend the visualization capabilities of the default Kubernetes workloads. I personally find it much better in terms of navigational capabilities. The support for cluster switching in the UI itself is another handy feature, and my personal favorite is the summary view, which shows all the links to a particular objects in one single location. So in terms of references, we can have a look at these couple of references. One is the Octant website itself, which is octant.dev, and the project which is supported by VMware on GitHub is the Octant. So these two resources are helpful if you want to learn more about Octant. So with that, I conclude this short demo. If you want to connect with me on any of these social media sites, these are the links where I am available. Thank you once again for watching this video. If you like this, please hit the like button and subscribe to the channel.